This is serious and no joke. It's been a couple of rough hours because there has been a huge supply chain attack on Axios. Yes, that Axios that has more than 80 million weekly downloads. Now, first things first. In order for you to check if you're affected, attached you find a link to an article, and I'll share more details in a second, but this is important. For you to check if you have been affected, you want to follow that link below and run the commands you see there for your operating system, Mac OS, Linux, Windows. They're all affected. You want to run these commands if you are affected, and especially if these steps here show that you have been compromised. You will need to rotate your secrets, change your passwords, consider your credentials, the API keys on your system, everything that is on your system stolen. Consider your password stolen, change it all, disable the API keys. This is really important. Now, what exactly happened? Axios, obviously, very popular JavaScript library, a library that can be used to send HTTP requests from, for example, a React app to a backend API. It's getting used a lot, as you can see, and some malicious code has been injected into this library. Now, this does not mean that the websites that use that library have been affected. It means instead that the systems where you installed that library, your MacBook, your PC, or maybe that VPS where you built your website, those have been compromised if you ran npm install, bun install, npm update, bun update, anything like that in the last couple of hours. There is a high danger that you have been affected. Again, I shared those checks you should run to check whether you have been affected. Now, how exactly did this all happen and what exactly is a supply chain attack? I'll also share, by the way, how you can secure yourself against attacks like this in the future. But first, let's understand what exactly happens and what a supply chain attack is. A supply chain attack is simply an attack that does not target your application code. The attacker doesn't try to directly infiltrate your system or your code base. Instead, they leverage the fact that your application code typically has dependencies which themselves have dependencies. So you have that dependency change, and the attack that targets this dependency chain, so it happens upstream from your code. So one of these dependencies has some malicious code due to an attack where that code was injected into it, not because the maintainer is trying to attack you, but instead, for example, like in this case, the account of a maintainer gets compromised, and the attacker uses that to then inject malicious code into some library, into some package, which another package may then be using, and your code may then be using that package that uses the malicious package, or maybe your application code directly pulls in the malicious dependency. Either way, one of your dependencies now suddenly comes with some malicious code, and the moment you run npm install or anything like that, or you update, that package gets downloaded onto your system, that malicious one, that affected one, and then it can execute malicious code on your system, typically with help of postinstall scripts. So in case you don't know, npm has this mechanism of scripts. We're all using them in our projects, for example, to start a dev server, to build our project, to run tests, stuff like that. And there specifically also are post-install scripts, which you might not be using when you're building a React app, for example, but which libraries often use, or may not often, but may use to run some code on your system after you install the library, typically not to do anything malicious or bad, but for example, to compile some code, create a binary that may be needed by that library, prepare your system in any way or form so that it can actually use that library you just downloaded. That is the idea behind a post-install script. It allows a package to define some code that should be executed after it has been installed through npm install, for example. And that's exactly what gets leveraged typically in those supply chain attacks. The attacker injects some malicious code into a package that is essentially a post install script that is executed automatically once the infected package has been installed. Typically, that code is obfuscated so that it's not easy to read. It could be base64 encoded so that scanners that scan packages for malicious code might not detect it, and or the malicious code may be downloaded. So the post install script, like in case here of the Axios attack, actually doesn't directly contain the malicious code. Instead, it contacts a server and downloads the code from there. That is what happened here. And we have a detailed report on what exactly happened during that attack. You find it attached if you want to read all the details. But in there, we essentially learn that two versions of the Axios package, 1.14.1 and 0.30.4, were affected, were compromised in the end. And that was done by the attacker getting access to the account of one of the Axios package maintainers, and they used that account to publish a new version of the Axios package that contained a dependency, which then in turn contained that post install script. So it was not even the Axios package itself that contained the post install script, but instead it was another package, the plain crypto.js package, which was created by the attacker, which sole purpose is to have a post install script that downloads and runs some malicious code. So the Axios package was compromised by adding plain crypto.js as a dependency to Axios. That is a malicious package. It serves no other purpose than downloading that malicious code. And just by adding this dependency to Axios, the attack was finished, essentially. This package is not imported into the Axios source code anywhere. It just has this post install script, and that is it. As mentioned, it then is able to download and run code from macOS, Windows, and Linux to then do what? Well, steal a bunch of stuff. So if your system is affected, as I mentioned initially, credentials, API keys, crypto tokens, all that fun stuff is being collected and exfiltrated by a Trojan that is downloaded by that post install script. That is how that attack worked. That is how similar attacks worked in the past. Now, what's kind of interesting, well, oh, by the way, this attack started around midnight, shortly after midnight, UTC, today, a few hours ago. It lasted for a couple of hours, and both Axios versions 1.14.1 and 0.30.4 were affected within 40 minutes, essentially 39 minutes to be precise. So this was a very orchestrated, planned attack. Obviously, the creation of this extra package happened, I think, 18 hours before the attack started. So yeah, very orchestrated and planned. Now, what's a bit weird here is that NPM has this mechanism called trusted publishing, which can be used by package maintainers. And the idea here is that that limits the publishing process of new versions of a package to a clearly defined process where specifically you have to build and publish a new version through one of these supported CI/CD providers with a certain setup you have to go through. And the idea here is that even if your NPM account credentials get stolen, in theory, the attacker can't publish a new version of your package from their machine because they need to go through that process. Now, you could argue that if the GitHub account of a maintainer gets compromised, then maybe a malicious version can be pushed to GitHub, triggering that deploy workflow here, and therefore the malicious code gets published through that trusted publishing process. But according to the security report here, that is not what happened here, because the Axios team is using this trusted publishing process for the 1.x branch, not for the 0.30 branch, but for the 1.x branch. But according to this report, there is no commit or tag in the Axios GitHub repository, so there wasn't a push to GitHub with that compromised version of Axios. So the trusted publishing process shouldn't have been triggered. Instead, this report states that the attacker must have obtained a long-lived classic NPM access token for publishing this malicious or this compromised version of Axios, because the release only existed on NPM, not on GitHub. Maybe this is wrong. Maybe the attack went through GitHub. If it is correct, though, it's not clear to me how exactly it worked, because in theory, this way of publishing should not be possible when trusted publishing is turned on. Not sure if this is some security vulnerability or some problem with NPM here, that some existing long-lived tokens could still be used even with trusted publishing turned on. That is something I was not able to find out how exactly that worked out. And there is a thread here, a GitHub issue on the Axios library where this attack was reported. By the way, side note, more such issues have been created and they were deleted by the compromised maintainer, by the account of the compromised maintainer. This thread, this issue survived and the attack was stopped eventually. They regained access to their account, that maintainer that was affected. And in that thread, in that issue, the maintainer posts and said that they are using trusted publishing and it's not clear how exactly that worked. Here is a theory that was shared, but my understanding is that this theory would still require a new malicious or compromised version being pushed to GitHub. But again, that's all not clear. What is clear is that compromised versions have been published and ended up on NPM and therefore could be downloaded on systems and steal stuff there. And of course, with over 80 million weekly downloads, there is a lot of damage to be done within a few hours. Obviously, downloads are not evenly distributed across all hours during a day. But this is definitely a huge number, and we can assume that thousands, tens of thousands of systems have been affected within those few hours. Now, of course, this wasn't the first supply chain attack. Over the last months, we've seen multiple attacks. One big attack at the end of last year, the Schwarzmüller attack, where multiple packages were affected on NPM, and that had a similar pattern, malicious code being injected and executed on systems that downloaded those compromised packages, and then credentials and stuff being stolen. So that is one big attack. And then only a few days ago, we had a similar incident in the Python ecosystem. So it's not limited to JavaScript, where the Lite LLM package was affected. Very popular package that in the end makes it easier to use AI providers through one convenient interface. That also had a similar attack and was affected. And therefore, it's of course not just JavaScript. And I think there are a couple of reasons why we see more such attacks happening. Because in theory, these kinds of attacks could have happened and probably did happen in the past too, but clearly they are becoming more frequent now. And I think there are a couple of reasons for that. Now, of course, one big reason is that we're at a point in time where more code than ever is being written, generated. I mean, you can look at various metrics. For example, I saw this chart recently that the number of new GitHub repositories being created is at an all-time high. And of course, that is because of AI. More people are working on projects, are generating code. We have more code output than ever before. And of course, that means with so much more programs being written, so much more code being generated, the attack surface is so much bigger. There are more targets. There are more people building or writing code and installing packages. So it's more attractive than ever. Not that it was not attractive in the past, but now there are more people than ever that can be attacked. So that's, of course, one big reason. It's simply more interesting to run these attacks, but it's not the only one. I think another reason, of course, also is related to AI, that for one, running such attacks like this with help of AI probably got easier. For one, because the malicious code can, of course, also be generated and written with help of AI. So the technical skills needed to run such attacks are more available than in the past, I would argue, though you could also buy scripts or Trojans like this in the darknet, but still, It might be more accessible to people. It's, of course, not just the good side of AI, that more people can build software and turn their ideas into businesses or whatever, but it's also the bad stuff. More people can do bad things related to code thanks to AI. So that is one reason. You could also argue that, of course, package maintainers, library maintainers, are swamped with pull requests. That's another big issue we have these days, that if you're an open source maintainer, there's more pull requests coming in than ever before. So you might not be super careful with what you merge. Not the problem here, just to be clear. In this Axios attack here, clearly it was a compromised account, but you could in theory make the argument that it would be possible that maintainers merge malicious code or code that installs malicious dependencies into their library because they just overlook it, or maybe because they have a fully automated code review process that doesn't catch it. They're just relying on AI. Again, not the case here, but you could think that this could in the future be used by attackers, that they inject malicious code into code bases because people just don't look. In addition, when you're using Claude Code, OpenClaw, whatever on your system to do all kinds of work for you, not just help you work on software, but maybe just manage your system as a whole, of course, for certain tasks, OpenClaw, Claude Code, Codex, whatever, they may decide to write some script and run some code to do a certain task you asked them to do. And that code they generated may also rely on dependencies like Axios. So again, the attack surface getting bigger. That's my first argument again, but outside of just classic software development. And for all these reasons, and probably many other reasons I didn't think about here, these attacks are getting more lucrative, easier to do, and more interesting to do. And that is why I'm certain we'll see more of these attacks in the future. Now, what can you do to prevent such attacks, to protect yourself? One big security step up, one thing you can do is in all your projects where you're working on applications and so on, when you're using tools like PNPM instead of NPM for managing your dependencies, you can add a minimum release age setting to your PNPM workspace YAML file. Bun has a similar feature. You can add a bunfig TOML file if you're using Bun as a package manager, and they also have a minimum release age setting you can add in that file. What does this do? It simply ensures that whenever you install a package, no matter how, it only installs packages that are at least that old, or package versions that are at least that old. So if a package was compromised 5 hours ago, but you have a rule that only installs versions that are at least 3 days old, you should be safe. That is the idea. And unfortunately, NPM itself doesn't have that. Now, just to be sure, or that this is clear, we're still talking about packages that are hosted on NPM. That is not the problem. I'm talking about the package manager here. And you can, of course, use Bun or PNPM to download those packages from NPM. And if you are using them instead of just NPM, the tool itself, then you can take advantage of settings like this, which simply give you that extra security layer, because typically in the past, those attacks have been caught within a couple of hours. So if you have like a 3-day threshold, for example, most of these attacks will have been caught by then and will be over. It's not 100% secure, of course. An attack could last for longer, but it gives you a clear advantage, and it's definitely a good thing to do. Now, to be even more secure, you can and should consider using solutions like Doppler. And this is not sponsored. This is just one example. There are alternatives. I built my own alternative, actually, which I'm using myself, which are services or tools that manage your secrets. So something like your OpenAI API key, you could put that in a .env file, but it's better to store it encrypted in, or with help of a service like Doppler on their servers, or self-hosted on a VPS you own, and then you inject it into the environment for your application to be aware of it and to use it when needed, so that if you had a Trojan on your system that maybe fetches all your .env files and extracts the information out of them, it doesn't find any secrets in there. That's the idea. So storing those secrets not in text files on your system, and a .env file is just a text file in the end, but instead encrypted somewhere else, is definitely also something you might want to consider doing. And again, there are different solutions here, but it is something you might want to consider. And to be even more secure, of course, you could outsource your development environment and not have it on your MacBook, your machine, your PC, but instead have it on a VPS, on a Mac Mini, to which you connect via SSH or something like that, or maybe in a Docker container, so that if some malicious code would be executed there, it only affects that Docker container, that VPS, and not your entire system. So it can't gather all your system passwords and stuff like that. Instead, it's isolated. You have a smaller blast radius, because those attacks will keep on happening. Obviously, I'm pretty sure we'll have better and better mechanisms to secure publishing of packages and so on, but there will never be a 100% guarantee that such attacks can't happen. And therefore, you as a user of such packages, you must secure your system and have multiple layers of defense there, so that you decrease the chance of you downloading a compromised package version. And if you do, the blast radius is smaller. That is what you can do. I'll share more on that in future videos, also on my other channel, the Academine channel. But yeah, stay safe out there. Check if you have been affected by this attack. And yeah, it's been a couple of rough hours, as I mentioned.